Okay, so we are into Unit 2, Day 1, absolute value. And absolute value equations. Absolute value equations. And if you write reasonably sized, it'll all fit on this one page. If you're a big writer, then maybe not, but I think it'll all fit. Well, let's start by reminding ourselves a little bit about absolute value. A couple of what I think are easy example problems, just to get our brain warmed up. Right, so what's the absolute value of negative 7? 7, good. And the absolute value of 7? 7. Okay, that's the stuff that we already know. Absolute value turns things positive. A better way to think about absolute value is how far it is from 0. Negative 7 is 7 away from 0. 7 is 7 away from 0. So the answer always ends up being positive. Okay, what's new, I think, although, oops, that's supposed to be a star. With what you know, I think you'll be able to answer this question a little bit backwards. If the absolute value of x is equal to 7, so now we know the answer is 7, like we know the output, use the term from last unit, and we want to know the input, we have to think about, well, what was x if the answer is 7? And that's it. 7 or negative 7. Then x equals negative 7 or x equals 7. Right? Either one of those would have worked. Now, that's the theory for the rest of the lesson. So if that makes sense, we should be good the rest of the way. Let's outline some steps for when the problems get a little bit harder than you can tell the answer by just looking at it. So I'm going to do the steps on the left and work an example on the right. It's kind of a two-column thing here. We'll list the steps and work the example as we go. Step 1 is isolate the absolute value. Isolate the absolute value. So get it by itself. Now, in that silly example number 3, it was already like that. So that's part of what made 3 easier than what the rest of our problems will be. So let's start with, our example is going to be 3, absolute value x minus 2 plus 2 equals 14. Okay, so there's the absolute value piece. And we want to get that by itself first. So I'm not worried about how to handle that yet. Just pretend that that's what we're trying to get by itself, and then we'll worry about that. So what should I do to start to get that chunk of stuff by itself? Subtract 2. Are we good enough to do 2 steps at once and save paper? After I subtract 2, what would I do next? Divide by 3. Sir. Samuel, here's the... On like the 3rd page is blank, and that's where we're putting these notes. Okay, so if I subtract 2, that gets me to 12. If I divide by 3, that gets me to 4. So just kind of in the interest of saving space here, subtract 2, divide by 3, I get 4. Okay, well this is a little bit like that number 3 from earlier. I can cover that thing up right there. So if the absolute value of something equals 4, what would have to be hidden underneath the Sharpie there?
4 or negative 4.
4 or negative 4. Right? The only thing that would work is if what's on the inside is 4 or negative 4. So what we're going to do now, we're going to solve 2 with an extra, there we go, 2 easier equations. because what's inside is always equal to the positive or the negative from the other side. X minus 2 equals 4, or x minus 2 equals negative 4. And again, once you get to this step, you're solving two like algebra 1 level equations. So x equals 6 or x equals negative 2. So isolate it and then split it up. Make sure you isolate first, right? You can't just say all of this stuff equals positive and negative 14. That's not true. You got to get the absolute value thing by itself and then realize that what's inside there is either 4 or negative 4. Okay.
Oh, never mind. Thank you.
You're welcome. That was an easy one. Now, there's an extra, this happens sometimes in math, I think you've seen this before, where we must check our answers, not just because we're good math students and we want to make sure we got the problem right, but because there might be, the fancy word for solutions that we get, we didn't make any mistakes, but they don't actually work. The first part of the word makes sense. They're extra, but the word is extraneous. Extraneous solutions. Those are solutions that you didn't do anything wrong, but they still don't work in the problem. So let's check ours. We'll check, got to check 6 and negative 6 here. And when we check them all the way back in the original. So 3 times 6 minus 2 plus 2 equals 14. And how much work you show is kind of up to you. 6 minus 2 is 4, times 3 is 12, plus 2 is 14. Check, that one worked. Thank you. We'll get that in a minute. Let's check the other one. So 3 absolute value negative 2 minus 2 plus 2 equals 14. Let's see. Negative 2 minus 2 is negative 4. But what's the absolute value of negative 4? For some reason this throws people off. Like they know if I ask you the absolute value of negative 4, you know it's 4. But somehow when it comes to equations, people forget that you use the absolute value there. 3 times positive 4 plus 2, 12 plus 2 equals 14. So yeah, we're good. Okay, we'll see one in a minute that doesn't work, and you'll understand why we have to check them. Okay, let's do a couple more examples here. Negative 2, absolute value x minus 4 equals negative 10. Again, job 1, get the absolute value thing by itself first before you split it up. Okay, people are eager and I guess correct to be looking ahead to like, oh, it's absolute value, I'm going to split it up into the plus and minus. That's true, but you don't split it up until the absolute value thing is by itself. So what should we do first on this one? Yeah, let's divide by negative 2. So absolute value of x minus 4 equals 5. Okay, now I've got the absolute value thing by itself. Now I'm ready to split it into two equations. So the first equation will just be x minus 4 equals 5. Hesitant to call it a popsicle stick yet. What's the second equation going to be? X minus 4. You only change Okay, so what's inside there, look, what's under the pin has to be a positive or negative 5. Right? If the absolute value equals 5, then what's behind my pin has to be a positive or negative 5. So that means x minus 4 is 5, or x minus 4 is negative 5. Okay? Don't change the inside of the absolute value, only change the answer on the other side. So x equals 9, x equals negative 1. But we need to check those. Negative 2, absolute value, 9 minus 4. Let's see, is that right? 9 minus 4 is 5, times negative 2 is negative 10. So the 9 works. Let's check the negative 1. This is the one that throws people off. Negative 1 minus 4 is negative 5. What is the absolute value of negative 5? 5. Negative 2 times 5 is negative 10, so that one works as well. Isolate and then split it up. Man, I said this would fit on one page and it's not looking good. Example 3. 5, absolute value, 3x plus 1, minus 20x equals 10. Okay, obviously this one's a little more complicated than that last one. But our job's still the same. Get this guy by itself first, and then split it up. So, what do you want to do first to start to get that chunk by itself?
Divide by 5.
Good. You can divide by 5 or move the 20x over, either way. But dividing by 5 sort of reduces everybody, so I like that one. Let's divide by 5. Divide everybody by 5. Kind of simplify the whole equation there. Still trying to get the absolute value chunked by itself. So what should I do next?
Plus 4x.
Good. Add the 4x over. Okay. This one definitely looks weirder than the other because I've got x's on both sides. But remember, this means that whatever's in under my pin there, under my pinky, that's either equal to 4x plus 2, or, again, don't change the inside stuff, or it's equal to, do you know what else it might be equal to? Good. Put the negative on everything, so negative 4x minus 2. So we isolate and then split, and now we've got two Algebra 1 level equations to solve. So x equals negative 1. Right, subtract 3x from both sides, subtract the 2 from both sides. This one, not quite as easy. 7x equals negative 3. So x equals negative 3/7. But we'll have to test both of those. That's the end of the page, but I'm almost done, so this will be okay. So I got to test negative 1. When you test it, you got to test it all the way back in the original. Way back at the start. 5 parentheses 3 times negative 1 plus 1 minus 20 times negative 1. Because if x is negative 1, it has to go in everywhere that x is. A few people messed that up on the test. There was an f of x equals something, and it had 2 x's in it. You kind of put the input into both places. Few people only did it in one spot. Okay, let's see. Well, can't do all this in my head. Negative 3 plus 1 is negative 2. What's the absolute value of negative 2? 2, so 5 times 2. Plus negative 20 times negative 1 would be a plus 20 equals 10. Wait a minute. 10 plus 20 equals 10. That's not true. That means that x does not equal negative 1. That's extraneous. So I've kind of double labeled that. I'll need you to do one of the two things. You definitely need to mark it out. Right? You don't want to leave it as x equals negative 1 because it didn't work. And then I'm going to label it as extraneous because I didn't do anything wrong. It just, the math sometimes messes up with positives and negatives. So x can't be negative 1. Negative 3/7 looks fishy, but let's see what happens. 5, 3 times... Wait. Nobody fixed my mistake when I made it earlier. Wait, that's not wrong. Did I do that right? Yeah, I did that right. Oh, backwards something there. Alright, in goes negative 3/7. All the way back at the beginning. Plus 1. Absolute value. Minus 20 times... Thank you. Negative 3/7 equals 10. Yay, fractions. Okay. Multiplying fractions, just multiply across. Do not multiply this to the top and the bottom. So that's negative 9/7 plus 1. And this would end up being plus 67. I'm really suspicious that this is going to work out, but let's see what happens. What's negative 9/7 plus 1? Negative 2/7, right? Because 1 is the same thing as 7/7. And what's the absolute value of negative 2/7? Trying to skip some steps here. So that would be 10/7 plus 60/7.
So it does.
77, which would be 10. Which would be 10, yeah. 77 would be 10. So this one did work. Okay. So there's a little bit of good news here. When you get a fraction, it's a pain to deal with initially, but whether it works or doesn't, you get down to something that works out. Like, you're not going to be stuck with crazy fractions. They're going to end up working out. So, don't be scared of fractions. Like, you can handle fractions. Okay, today's assignment is actually not in the packet, so apologies for that. First of all, put your name on it. And from earlier, this is today and tomorrow's assignment. So either finish it all in class today, finish it tonight, save some for tomorrow. I don't care how you split it up. Again, football game tonight messes with some people's schedules, so be careful. Let's look at 31 together here. Something happens on 31 that I want you to see. You know what? Why don't you just do 31, and then I'll work it up here. So try 31. Something kind of weird happens on 31. There's your warning. But the weird thing doesn't happen until the very end. So try 31, and if toward the very end you get something weird looking, you might be doing it right. Right? Isolate, separate, but then check. Oh, now I need another word that rhymes with isolate and separate. Investigate. Let's plug in 1 and see what happens.
When you compare the opposite So, I thought when you turn the absolute value to like a positive afterwards, why is it minus still? Except before.
So, like, right? Oh, that absolute value does not apply to the inside. It only applies at the end.
But when you like take the absolute value out, wouldn't that turn into a positive?
Right? That does not become 5 plus 2 equals 7. Right? You have to do the inside first and then apply the absolute value.
Yeah, what if you
So you can't just make that a plus 4 because it's inside the absolute value.
Taking out the absolute value.
It's talking about when 3x minus 4 equals negative 1 and positive 1.
Right here? You're right. I mean, you're on to something. Let's see what happens if we... I've made a mistake, but it's a mistake that many will continue to make.
Oh, so like there is a mistake in that.
2 plus... that doesn't work, so x equals 1 doesn't work. 5/3... Again, you have to be able to handle fractions like this. What's 3 times 5/3? What's even a better name than 15/3? 5, because the 3's canceled. So 5 minus 4 is 1. 2 plus 8 does not equal 6. So 5/3 is out. Now, here's where some of you caught it right away. Right here. Ben, this is what I think you were trying to get at. Maybe I should have paused right there. I've got absolute value of something equals negative 1. The absolute value of something equals negative 1. What could we take the absolute value of and get negative 1? Nothing. So if you get absolute value equals a negative, then you can stop there and say, wait a minute, this is not going to work. There's no solution. If you keep going, eventually you'll figure out there's no solution. But it would be much better if you were paying attention, understanding math rather than just applying formulas or applying methods, and caught it right here. Now, be careful that you can't do that unless you isolate and get a negative number.
But it's only if it's negative 1. If it's just positive 1, then it's still.
Right, that would be okay. You can't have an absolute value. Absolute value will never be equal to a negative.
Okay.
If that happens, you can stop the problem and say, no solution, I'm done. So what about 33? I got absolute value and a negative. Is that no solution?
No, because you need to.
Yeah, you're jumping ahead. You gotta get the absolute value thing by itself first. Then we can see if we can bail out on this. I mean, maybe we can, maybe we can't, but I don't know yet. If I add 12 to both sides, it gets me to 6. If I divide by negative 3, I get negative 2. And now I can say no solution. But don't, so some people, here's the two mistakes. There's the over mistake and the under mistake. The overdoing it mistake is, as soon as you see a negative, you're like, whoops, negatives, that don't work. No solution. Like, no, you got to do a little work before you know that. I don't see another one that's, like 41. There's a negative absolute value, that doesn't work. Like, no, you have to get a little further along than that. The other mistake is to not think about it at all and just work the problem like you work all the others. You should still catch it at the end, but so be careful. Use the shortcut, but the shortcut only works once you've isolated the absolute value. Then you can start thinking, well, is this going to work or not? All right, so I don't know if I was going to break it up for you. We get out at 8:10. I mean, I would try to finish 25, 20. I would try to do the first 3 today and maybe save the rest for tomorrow. That would be easy enough, I think. Again, if you want no homework for the...
I do 29.
Got a 0 in there. Well, I divide by 3 first.
Are you supposed to divide it by 3?
What's 0 divided by 3?
0.
Yep, so you can divide by 3. So, again, think back. Don't just think process, think concept. Think about what's going on. Absolute value of something equals 0. What does the something have to be? 0.
So just 0 for both of them.
Well, I guess you could write them both if you wanted to, plus 0 minus 0, but that doesn't really make sense. So it's just equal 0. Max? Okay, I'll get there in a second.
What is the answer? 2a minus 4 equals 0.
That's not the answer because I want to know what A equals.
2.
A equals 2.
What do you do with the 3?
You just
I divided by 3. So A equals 2. So then we check it. 4 minus 4 is 0. Yep. What's 3 times 0?
0.
0. So does this work? Yeah.
No.
3 times 0 is 0. I mean, we're kind of cruising ahead. If you're still struggling with fractions and integers and adding and subtracting, it's going to be a long year. Down to 33.
Yeah,
It's no solution, but you don't know that here. You just don't know anything yet. You only know that once you get to absolute value equals negative, then you can say no solution. Max, which one were you looking at? The one on the other side. So to get the absolute value thing by itself, I would move that negative over. And then split it up. 2z plus 4 equals negative 8z minus 20, and 2z plus 4 equals positive 8z plus 20. And my guess is one will work and one won't, but I don't know. I don't know that yet.
Wait, you just got the negative to the side by
Right, either one. Multiply by negative 1 or divide by negative 1. And then you split it up. That means 2z plus 4 equals negative 8z minus 20. Or 2z plus 4 equals, change the signs, 8z plus 20. Same process. More numbers, more letters, but same process. Again, we'll have tomorrow. I'll answer a few questions, maybe work a few together. We'll finish the worksheet, and so homework tonight, kind of maybe. Homework tomorrow, hopefully not.